all the different sorts of equations, the sum will still just say solve for x. In this particular case, you need to start looking more discerning at your questions. If we look at this question, there's something that repeats itself. The heading says K method, because K method can infiltrate anywhere. The place I taught it to you was with exponents, where there was a 3 to the 2x and another 3 to the 2x, and you could make that just a k, and that would make your sum a little bit easier, because that's the general idea behind K method, making your sum a little bit easier. So here, you have to see it. That's the main thing. You have to recognize that there's something that repeats itself, so that if I give K method, if I set K to something, it'll make my sum a little bit easier. What am I going to put equal to K?
X squared minus.
Do you see it repeating itself? The golden rule is still the golden rule. Once you have substituted with K, there cannot be K something something K something something X. Then you miss the point. If you substitute with K, it must be in terms of K. Once you've taken your equation and substituted K in, there can be no other stuff, just K. Are you with me? So we're going to set K equal to x squared minus 3x. So no, it's just a different type of thing. It's not exponential anymore, but you're still using the K method. So if I substitute K, this will be K squared minus 5K plus 4, which is a much nicer looking equation, because it's quadratic. It's already equal to 0, otherwise I would have to put it equal to 0. Then I will try to factorize it. If I can't, formula. Right, so for the factors, which you can do in whichever way, these are not very difficult. So K minus 4 and K minus 1, or you do James Bond, 1 times 1, 1 times 4, cross multiplies 4, cross multiplies 1, to get to negative 5, both are negative. K minus 1, K minus 4, just be careful that you don't say X if it's in terms of K. So that your answers are K is equal to 4, or K is equal to 1. Am I finished?
No.
I'm going to go back and say x squared minus 3x is equal to 4. But what is this? It's a quadratic equation. So it's equal to 4, but I'm going to go equal to 0, because there's another quadratic equation inside of the sum. Pay attention. This one will be x squared minus 3x equal to 1. Again, there's another quadratic equation that I'm going to put equal to 0. So I've got 2 more quadratic equations. Bringing across the 1 becomes a negative 1. So now I've got to go and find factors for this one, and what is it? 4. So that my answers are 4 or negative 1. The previous lesson we had exclusions. Any exclusions in the sum? And why not?
It's not a fraction.
There's not fractions that have denominators with variables in them. That one,
Formula.
you're going to have to go for the formula. You have no choice. I'm going to try and squish it in there. So for x squared minus 3x minus 1 equal to 0, substitution with b, which is negative 3, will become positive 3 over there. Remember, if you've got the new calculator, you would punch that in with a is 1, b is minus 3, c is minus 1, and you would get your answer in the form of a root. But you can't just give me that answer, you've got to show me. Formula, substitution. So negative 3 squared in the place of b. And be careful, if the formula is wrong, I cannot follow up. You've got the wrong recipe. Formula is wrong. Say for instance you've got a plus there, or you don't have a square there, or you don't have a plus minus there. Then you don't have the marks. Right? And at the bottom we have 2 times a, which is 1, and I missed this a, which was 1, and c, which was minus 1. Don't forget that it's minus. Then, either with your own calculator or with a brand new calculator, your answers would have been something in terms of fraction, a root. But the sums always say, solve for x, and where necessary, leave your answers to 2 decimals. So your answers here would have been 2 decimals, help me please. Only 2 answers. Either that or that to complete my answer. Now, how many answers are here going to be? 2 of them. How many were here? 2. So how many solutions for the whole sum? 4. But that can't be quadratic then. Can't be quadratic if there are 4 answers. Just give me an answer here.
Three.
Equals to 3,30.
Okay, round it off correctly, just concur and
0,3. 0.
okay, now if a question said 2 decimals, let's be technical. You have to have the 0 there. Are you with me? If I say 2 decimals, you actually have to have the 0 there. That's getting way technical. You're still right, but let's get technical and answer the question. Why are there 4 answers? Because this original sum, because we're busy with quadratic equations, quadratic. But is this a quadratic equation? It's not really. Because when I time all of this out, what is this sum going to become? If I have x squared minus 3x times x squared minus 3x, blah, 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 the rest of it. If you time this out, what's going to become?
X4.
And there's going to be x3 something, and there's going to be x3 something, and there's going to be x squared something, and other stuff as well. So do you know how to do a 4th power equation?
Yes.
Right. This is the reason why I want to show you this, because I want to clue you up for 0.1% chance that this happens somewhere in your life in a test. When you get there and you say, oh, I don't know, I want to tell you, if it's something to the power of 4, you should have used the. So this is something to take note of. If you go on the wrong route and start doing FOIL, timing it out, and you get to a point in the sum where you've got x to the full 3 and you say, I don't know how to do this. I hope that you'll remember you should have done K method. Alright, K method is so much easier, and actually technically we shouldn't be putting this with quadratic equations, but the principles are the same. If there's something that repeats itself, we put it equal to K. Alright, so 4 answers for that sum. If we had to sketch this thing, it would have been something like that, which has 1, 2, 3, 4 x-intercepts. Because what are x's? Because that's our next lesson. What are x's? The x-intercepts, or the other word for x's, the nature of the roots. How many roots does this equation have?
4.
4 roots. So 4 x-intercepts, and I don't know where the y-intercept, or the y-axis is, I don't know. I'm just making an assumption. If there are 4 x-intercepts, that means that you've got 4 roots. Or that's the other way of saying it. And if I asked you for the nature of these roots, what would my answer have been for the nature of the roots?
Real number.
They would have been real. They would have been
Good, what's the Q?
rational. And then what would you say about equal?
Unequal.
You can't say anything about that because those nature of the root things are especially for quadratic equations. But you're on the right track saying that they are real and that they are rational. Are they rational?
Yes.
Looking like that, yes. But it came from a
Irrational.
irrational number. You have rounded it off. So it shouldn't have been rational. It should have been
Irrational.
irrational. All right. That's enough for K method. One sum. K method. Are you with me, guys?
Yes.